coisas diferentes. Nesta
Antes de dizer as tecnologias,
eu não me quero fazer.
essa é uma das artigos.
Os últimos anos de direção no Algarve, temos alguns muitas pessoas mais ou menos
Sim. Se não tivesse lá no mais
Paulo, ceia,
explicaste
com a ação ceia, viagens, amistades pessoas. E no nosso caso, bastante é a parte do grupo. A gente também fisicamente está a Catarina, não precisa estar tentando.
Basicamente,
não vai, não. Sexta-feira uma mensagem para o canal, a ver se não vai. Mas desculpa, mas não vai.
Estamos prontos? Posso admitir as pessoas no digital e começar?
Sim. Vais ficar nesse lado, Érica?
Sim, queres que vá à sala? Posso ir.
Não. Pode estar.
Pronto. Are you ready to launch?
Consegues me ouvir, Érica?
Sim, sem problema.
Tá bem.
Pronto. Vá. 3, 2, 1.
Good morning, everyone. Welcome to Magal Altimetry Constellation final workshop where we will present the outcomes of this project that aims the studies of alternative paths to perform oceans monitoring through new space approach using CubeSat satellites. So the agenda for today will start with a brief introduction to what is Magal and what was the goals and objectives of Magal. It will follow a demonstration of the developing data center to integrate our service and products as final end user data. Then we will have a panel part focus on end user needs and wish regarding ocean monitoring from satellite data. We will have a brief break for lunchtime, followed by a demonstration of and presentation of the results of the custom radar altimeter developed in frame of the project and its prototype. And finally, a second panel debate in more business oriented regarding the finding of this new space sector, namely the oceans monitoring and the radar altimetry sector. We will end up with a summary or wrap up of the project and the main conclusions of the achievements on the project. So, Magal was a large consortium involving major Portuguese industry and science players. We have from industry Efacec, CEIA, Media. We have from science CIIMAR, Instituto Superior Técnico, Instituto de Telecomunicações, Paulo de Aveiro, University of Aveiro Interior, AquaColab plus Atlantic, Universidade dos Açores, Fundação Gaspar Frutuoso, Air Center, and we have as an international partner and also in the scope of the partnerships of the project, University of Texas, Austin, in this consortium. The project has a 3 years duration, starts in July 2020 and ends now, by the end of this month. It was funded by Portugal 2020, Compact 2020, Lisbon 2020, and Fundos Europeus Estruturais de Investimento in the scope of UT Austin Portuguese program. So, Magal aimed the development and leverage of the Portuguese space industry in all its supply chain, and Magal aims the conception of a constellation to monitoring oceans globally from the data acquisition to the user service and products. Furthermore, Magal also was meeting the national ocean programs and strategies performing as well as the needs identified by the satellite altimetry team for the project. As the project objectives, Magal proposed the development of a new concept of altimetry radar for global oceans and inland water bodies monitoring. It is based on small satellites built in the shape of new space. Magal project shall define the full architecture of its satellites, so the concept of satellites and constellation, identifying all required payloads and needs to functional operate satellites that can fulfill established requirements. These definitions shall accomplish a set of objectives that goes from science to entrepreneurial business, passing through engineering and technological areas in the full chain of its supply. Magal main developments are a custom radar altimeter and an integrated data center for end-use service and products. Magal is a proof of concept that using a constellation of small satellites for radar altimetry, never implemented before, can perform these science in the same way as traditional oceans monitoring oriented for new space market. Altimetry radar can be or can provide a broad set of services and products covering a large set of use cases. In order to set the architecture of Magal and study its feasibility solution, we are focused primarily in 4 objectives or 4 use cases and applications. So sea-surface topography, area detection and tracking, marine debris monitoring, and water levels. Nevertheless, this focus, there are other use cases that we can and surely in future we will apply its data to its studies. From these use cases, we have also oriented our business cases to 3 applications without any loss of information for other cases that surely we can adapt it without main change or main challenges. And these business cases that we have oriented our products and services are fisheries, marine protected areas fulfilling new European requirements directives, and natural disasters in all its broad scenarios. Magal key improvement that our concept will bring to the sector is its temporal solution that we will improve it to 5 days repetition time instead of current 10 one. At the same time that we keep identical special sampling accuracies and resolutions for all the other parameters. According to the project timeline, Magal shall end up at a CDR level. What we have achieved during the execution of the project was we were able to define all system requirements, deriving or starting from science and focus, as we said, in our use cases. And from this set of the requirements, we have derived a preliminary design. So we have performed its PDR. We have set a baseline architecture. We have identified all the payloads needs to perform its function. We have identified and selected all payloads from market available COTS components to build and in fact manufacture satellite, fulfilling our needs and our requirements. So, and with respect to design consolidation, so CDR level, we were not able to end up with full consolidation of the payloads. We have some consolidated, the most critical ones. There are others that we could not consolidate to some issues during the execution of the project and also time to do it. Regarding Constellation orbital parameters of Magal, Magal will be low Earth orbit constellation in the sun sequence orbit. So it will be a low SSO orbit, roughly at 500 kilometers. It will use 6 satellites. We will have an orbital period about 90 minutes. So something special sampling rate that's about 90 kilometers at equator level. We have a grand repetition track orbit, a precise one, with a maximum error of about 1 kilometer. For this, we have a precise attitude control of satellites and a lot of payloads in that frame. Also, we have precise and good instrumentation on board of satellite to have native pointing, a precise native pointing to correct and improve the accuracy of radar altimetry measurements at the end. And we have also included or integrated into the Magal design the concepts regarding its end of life and the orbiting parameters, which shall be achieved in about 5 to 7 years after its end of life. Regarding satellite platform design itself, we have a broad set of payloads, as I said. So the most accurate and precise, or the largest set of equipments are linked to the attitude control of the satellite in order to provide and also gives us precise attitude information of the Magal satellite position and information to be able to in post-processing correct and achieve required or needed radar altimetry performance to perform the oceans monitoring with 2-3 centimeters error at the end that is low and needs to perform science on it. At grant level, Magal foresees partnerships for medium long term for its ground station and control center. So we haven't developed or studied ground stations or control centers facilities to be developed in Magal scope. Here we will use the available ones through partnerships. We have developed a data center that will aggregate all the Magal data, but not only, it will also integrate additional and available other sources to provide additional and more information on service and products. Regarding the primary payload of Magal, it is based on a custom radar altimeter working at Q band. Sorry, there is a typo on the presentation. At 13 giga, based on FMCW technology and using some internal post-processing to allow us to achieve about 20 centimeters maximum error in its single measurement distance to the oceans. Additionally, we have a secondary payload for improve our accuracy of the orbit of the satellite. That is a laser reflector array during its calibration and in service of satellite. As main satellite design goals, we have Magal will be a CubeSat 24U shape with a total mass around 50 to 60 kilo. This is mainly due to the radar altimeter deployable antenna that we will see later, with a power budget in between 60 to 18 watts. It will use the mono or bipropellant propulsion system. We estimate that satellite cost will be less than 500,000 euros, which means a constellation below 3 million euros. And the launch cost, it's highly depending on selected vehicle and launch schedule opportunities. We have pointed out in worst case launch cost below 6 million. Magal satellite is expected to have a minimum lifetime of 3 years, and it is based on codes from military and automotive grade level. So we will move now to the data center presentation. That I will pass the floor to my colleague Paulo from CIIMAR that will perform this presentation. Thank you.
So, good morning. So, in terms of data analysis center, we have developed a platform, and in the previous state, we want to have a platform that we can have specific services and products, so we can have all these products in the same platform. We want to have not only the data from the Magal constellation itself, but data that we can correlate this data with data from other sources. Because we know that, for example, from in terms of grades, in terms of grades that we do for specific products, we'll have to have the information from Magal, not only the information from Magal, but the information from other sources. So we want to have a platform that can aggregate all this data, all this information from satellite itself, but from as well other sources. And for example, what about if we want to have this information, and for example, and you match that information, for example, with vessels in a specific location to check if there is anything that we can check and analyze in order to have accuracy from our models. So we have this, we want to have this platform, a platform web-based that can be accessed from everywhere. A platform that can have a set of services according to users' specification. For example, for a specific user, I can have a specific product and with in a specific maturity level, but for another user, I can have only the final product. For example, in terms of aquaculture, I believe that the researcher, the final customer, stakeholder, will want to have a single product. The visualization of each field. He wants to have the product itself. He wants to have. He wants to check and to analyze to have that data in order that he can see the information and check what is on that information. We have developed this platform that is a service-based architecture. It is built on microservices, meaning that we can have a specific product for a specific user. For example, let's just say that, for example, for researchers, they want to have the sea level anomaly, or they can want to have a specific product. But if you want a level 4 product for a specific customer, you'll have the access to have that product for this specific customer. So have that microservice-based development. It must be able to receive and use both bus and parallel data. Some of this information will not be available for public, of course, but some of the information we can match. We can see if there is any misleading information that could affect the data. And then, of course, the different products will be provided to different customers, stakeholders, value over data, correlation with different data sources, and the data, of course, must be validated for our consortium. Or if we get data from other sources, for example, Sentinel-3, Sentinel-2, Sentinel-1, if needed, we will have that information in our platform. The data must be validated. That's must have. So this was the main assumption that we have developed for Data Analysis Center. Then, with this information, we have developed a main architecture for development. We are talking about a software development. So we need to have a backend development that will have data from the satellite Magal itself, from our partners, but data as well from the platforms. For example, we have access for parent data. We have direct access to CDS or CIIMAR's data. So we have that information, and we are acquiring the information through our backend. Then the data gets into the data analysis center, our data analysis center, and we will work on that data to check if that data fits what is intended to have, if the data is feasible or not, and we will apply some information on that data. We'll check if that information corresponds to what is expected to have in the information. Then we will have as well the data in front end, the dashboard, the access that the final user will have to check all this data into the platform. So this is the main architecture, and what we have there on the right side is that part of different products for different users. And all that information in a single platform, and they can access the information according to its permissions. And then we have here the decks. Awesome.
Yes. The workflow process here, we use the DAG approach for the extract, transform, and load all the information from external data sources. And we have to do, we did some assumptions here. So we had to, after finding the product, and here the first assumption is to load just level 4 products, okay? And after that, we needed to to define some subsets. So the geospatial subset and the temporal subset, and after that we have designed the workflow, the ETL workflow, in order to deploy on the data server. So, and here we have used a threads data server in order to deploy all the information on a daily basis and to serve, in order to serve the front end of the data analysis platform. So after this, can I
just say one thing? This methodology, this DAG methodology, is very useful because with this methodology, it works in the nodes in each one of these processes. Each one of the boxes is a process. And what we can have in this process is just that, like the name states, DAG for data, a cyclic graph. We can have this information without the infinite cycles that can happen sometimes. So we can reduce the time and to improve the efficiency of the development. It's a methodology that we have chosen in order to reduce and to reduce the waiting times, cyclic times. Sometimes we have for long periods of time, and then we can have this information in a very precise manner. Then,
sorry, Paul. Just to say that we have here a lot of dependencies, so we have to take into account the reliability of the external services from our platform, from the external platform, from the available data. So there's a lot of things that we need to pay attention and in order to ensure that the data comes in a daily basis with reliable and in a continuous way. Yes.
So, in terms of data analysis centers, so we wanted this platform to provide data and products to final users. So this is the typical flow. So we have typical space segments, we have then the ground segments, and we have, of course, the so-called ground, the data analysis center. So we have this information that can be provided from two sources, either from the Magal itself when it's ready to send us data, but we are also having data from other sources, for example, from a submission, from a MetSat, that we are acquiring that data. Then that information will pass to the ground control station, which will be later sent to the data analysis center. So in terms of the data analysis center, we have our data hub that will get this data in our platform.
Yes, about the other segments, so we have there the meteorology data, temperature, clouds, precipitation, and so on, nautical charts, and the AES service, but also the CIIMAR products, CDS products. So, as I said, level 4 products, the sea level anomaly, products from sea surface temperature, from the SEL, STR, from Sentinel-3, from the all-sea products as well. I just want you to know that we can extend this information. We can have more and more information to the data center, because we have the pipeline. The workflow is working, and now we just have to find the products, the gridded product, level 4 products, in order to have the new products to the platform. I just want you to show our threads data server. I don't think it's possible because for limitations of the network. If you go here to okay, this one.
Due to permissions, we are accessing
yes.
our own.
I'm trying to connect to my hotspot in order to demonstrate our threads data server. It's working. No. I was trying to connect to our Wi-Fi network, my hotspot.
Okay. This one?
Yeah. No, it's with no internet. Yeah, I don't think it's possible to show you our threads data server. It was just an example of the sea level anomaly product served on our threads for the subset that we have chosen for the North Atlantic area and for 1 month of data. Okay, so this was a criteria chosen by us in order to serve. We don't want to serve all the information globally. Now we have to be restricted on the temporal data and the geospatial data. So we have chosen a subset for the North Atlantic area, and we are serving the data just for the last month available on this case on the CDS platform. Okay, but that's okay, no problem.
We can put later some images on the
Yes.
in our SharePoint, so you can all check.
Yeah.
Okay.
Just a second to scroll back.
So in terms of completion, we have developed the platform. The platform useful is it was already sent to all the consortium, so we can test, so we can check, and so you can send us as well some feedback in order to improve our data analysis. This is the first approach. We are expecting to improve it. So we have developed we have all development performed. However, we are expecting to have your feedback so you can improve this platform. So this platform can be useful not only for our final users, final stakeholders, yeah, sure, but also for researchers. So researchers can come here and can, okay, I'll now download extra information from the specific satellite. I'll have all this data, for example, from CDS, from CIIMAR, and so on, and I'll acquire this data through the platform. So we are waiting for your feedback so you can improve. In terms of completion, next, the box that we have so far is the SFTP for external data integration, namely with our partners. If we need to run some information, we'll need that part from you, so we can exchange data in a common basis. So, for example, in terms of using the information, for example, in terms of corrections and so on, we can agile the process. With that done, we'll fulfill everything. In terms of next developments, this is the developments for this week, maybe middle of the next week. We have delays as well from CDS and from CIIMAR. They are already, the DAGs are already developed, the APIs are already linked, and so on. We just need to have them right on the precise location. Every time we download a product, for example, from OBS, it will appear directly over the map. So this is what we are doing so far, and we are hoping to have it finished by the end of this week, but maybe 1 or 2 more days, and we'll have all this information. And now we can see a video from the Data Analysis Center that can be what has been done in Data Analysis Center. So you have the login and the registration webpage. All the data from each one of the users are confidential. No one knows about it, and they use typical developments. So then we have the about project spreadsheet that can check all the funding mechanisms as well as all the partners. It can be checked, it can be linked. Then see, for example, the home button. They can check the map over the map in order to select the area that we want to check and to analyze, because we need to resize it every time. For example, it's not possible to have data from 30 years into all the world. The platform will take a lot of processing necessity in it in order to run all of that. So we were narrowing by having a square to have the information from that part. So for example, this is the part from that we can have the data, for example, in this point, the data from Sentinel-2. We have also implemented Sentinel-1, Sentinel-2, and Sentinel-3. So we can have all this information from this point. We can have the data, and we can have the thumbnails, the layer of that image over the map. So we can check that information, as you can see right now. Okay. This is some of the information from Sentinel-2, and now we can search for data, we can narrow it. We can have also the footprint that we can check where it belongs, and information on the right sides. We can download it from the platform, and we can check additional info regarding the information that is on the platform itself. In order for it to check, okay, is this information that I want or is it not? So we can have, for example, here we can have the satellite. They will check for Sentinel-3, for example. At this point, the Alt-2. So they are searching for it, and we will see that information from that specific spot, and we can.
Okay, I just want to stress here that we have available already the land and the sea data products. So the land, the Sentinel land products came from the Copernicus CIIMAR platform, and the ocean Sentinel-3 data products came from Efacec. Okay, so there are different platforms, and here we have already both platforms as well integrated in order to deploy and to have access to both land and ocean products. Okay.
Thank you, Nelson. So continuing the video, so we haven't put all the layers because there is a lot of layers that you can check. But for example, we are now checking the Sentinel-3. We will soon have, until the end of the week, the CDS and CIIMAR. There is until the end of the week is our provision to have those products on the platform. And Sentinel-3, and now the SLTR, defining the spots and so on. The video is a little bit long, 4 minutes, but okay. And now checking the other products from Sentinel-3 directly. And on the right side, you see then that we have another type of layers. For example, we have the protected areas on the sea that the government that decided to have those areas protected. For example, we'll have the data from AIS, the automatic identification system that is presented in each one of the vessels above 20 meters. So we can have all that information. We can check precisely where that information is right now. We have as well the cartography with bathymetries, with cartography. We have the nautical charts. And we have as well the meteorological layers, for example, pressure, temperature, and so on. This is the AIS that you can see here, and you can match that information with information from Sentinel. We can check, for example, in a specific moment, in a specific time, if the information that we get from Sentinel-2 matches with information from AIS. We can check, is this feasible? What is happening or not? Why is that? Because, for example, in terms of some vessels, during the typical procedure, they will release, before entering port, they used to clean the tanks, sending all the remaining oils to the sea. And now here we can check and we can match that information to the tanks if this happens. So I have all this information, and this is the presentation regarding the data analysis center. Okay.
Thank you, Paul and Nelson. Anyone has questions about the data center? You can write on Q&A, and we will highlight or try to answer those questions to everyone. João, have you got something on Q&A? In your case, you can speak also. You can.
Okay, I wanted to ask a question, but I was going to read it down.
Okay. But you can write it.
Okay.
Okay.
So first of all, Paulo, nice to see you again.
Nice.
Thank you for the presentation. I saw in your presentation, I saw like a small public API thingy over there. Can a user interact with your platform through the API instead of instead of going to the front end, going to the back door to collect all the information needed when needed through programs, to scripts or whatever?
We have the API as well. We have the link to the API we have sent before, the link. So if they want to have this access through the API, they can now have it, the information to the API.
Okay.
Not to have high volumes of data. It's available.
And the other question is, all the external products that you use, you don't change the metadata of them. So the metadata is the metadata that.
Yes, the original metadata.
Original.
Without change.
Great, thank you.
Thank you again. Good again.
Yeah, I had also thank you for the presentation. I had some couple of questions. So you mentioned that you are already getting data from Copernicus.
Yes.
But Copernicus is now changing their data ecosystem. So have you accounted for that? Are you looking at that, or it's already with this new data space ecosystem that it's going to be fully operational in July, I think?
We have the specific point right now is working with data database, and we have the next roadmap. When they change, we'll change the pattern. That's what I think that's
and that related to that is that the new data space will allow also interaction with different external users, apparently. So could I access Magal data through the Copernicus data space ecosystem in the future, or something to think about? Because then that would increase the amount of users that could use it.
Right now it's not defined.
Yeah. And another thing is you said we can download the data, and I think this is related to what João asked. Is there any tools here that I can maybe do my processing and not downloading the data? Because the benefits of having this is actually receive data, having different kinds of data. So if I have to download everything, it might not be very.
Yes, the concepts behind the data center is that right now we are downloading and having all this information in the platform. In the future, we are developing as well. We are continuing to develop the platform to have the information, and we can have products, final products into the project. For example, through a request that wants specific products into the.
But it's always a market, kind of a marketplace that you request and someone does for us. Yes. Otherwise, it's like João asked, you can just do an API to try to get data. And then you will monetize that data. Or is it freely available data?
If the data is free, just find it that is free.
Okay.
Okay. If it's free from any of the data sources, it will be free to find out. One is expected to be only paid for a specific value when there is processing over that data, not the data that we acquired from other platforms. Okay.
Another question is you were seeing all the images, footprints, no? Yes. And you are cutting to the specific area of Portugal. Are you doing a composite also of all those images that can be usable or not?
Yeah, right now we are having the footprint according to what is provided from the Copernicus, for example. In future, what we want to have, for example, in terms of cross from CDR and from CMAPs, we will draw a square or a polygon, and we'll have the information only for that sensor. Okay, it will have, of course, some restrictions. For example, not be possible to have all the world for data from 50 numbers, 30 years ago. Okay, because it will need to have a lot of resources from the platform. So we are now narrowing to specific times like 1. It will depend on the size of the box that we perform, or depends on the data that we have. If we have data, for example, 30 years, a lot of information. We're talking about many data we have, many files from CIS.
20 gigabytes or something. So it's
very difficult to have all working on the platform.
Thank you, Carolina, for these questions. Thank you, Paulo and Sayer, for the answers and explanations. So we will move now to our first panel part that we will address the end users' needs and wishes on this sector. So we will have the view from science, technology, and end users with respect to this topic. We will have as moderator for this panel part Carolina Star from PT Space. She's responsible of third observation project officer at PT Space. And we will have as panelists also here Dr. Fabiola Amorim from CIIMAR, that is a researcher there. We will have also Dr. Paulo Relvas, a professor from University of Algarve. Dr. João Janeiro, currently researcher at S2 AquaColab, also in Algarve, and Professor Dr. Byron Tapley from UT Austin on this panel. Carolina, I will let you introduce yourself better, and also then I will ask all the panelists to brief description of that. I will just inform the attendees online that if they want to raise or put questions, to do it through the Q&A panel on the event, and we will try to address all of them during this discussion.
Okay. Thank you very much, Arlindo. I don't know, can you confirm just that you can hear me online?
Perfectly.
Yes, great. Thank you. Okay, so thank you very much for inviting me to be here. So I'm Carolina. I'm from the Portuguese Space Agency, and I'm following the Earth observation projects. And it's very interesting to be here to understand a bit the developments made under the Magal constellation. So we have here, and Arlindo already introduced the 4 panelists. To my right here, Dr. Fabiola Amorim from CIIMAR, Professor Paulo Relvas, Universidade do Algarve, Dr. Byron Tapley from US, from UT Austin. Hi, thank you for joining us. I believe it's not I don't know what time is it there, but thank you for joining us. And João, also from Algarve, from the C2 Aqua from AquaColab. So I would start, because I think you know better your job than me. So I would start just to do a quick roundtable for you to introduce to the audience and just give 1 minute, 2 minute maximum of your work and what you find it's relevant from your work to this panel. So Fabiola, you want to start or? Okay.
Thank you. First of all, thank you for the invitation. I like the initiative, and I think it's really interesting for one's work with the ocean, like me. So I've been working with first the observational data to describe the ocean features, and the use of satellite and color and remote sense data is quite valuable for me. And also I implement ocean models to describe the ocean currents and the features in the subscale and medscale resolutions. And also I use semi-Lagrangian tools and Lagrangian tools to track drifters in the ocean, passive or non-passive, and through the water column. So usually I use the satellite and remote sense data first to track these features in the ocean, and then evaluate and validate the ocean models to see how it works through the water column, basically.
Thank you very much. Dr. Byron, can you go next? Thank you.
Yes, the role that we've essentially been, is this coming through? Just be sure that.
Yes, perfectly. Thank you so much.
Yeah, the role that we've essentially been focusing on predominantly is the measurement per se, and the challenge of trying to essentially come up with a comprehensive measurement from satellite altitude in implementing what in the micro, the small sat, nanosat domain, what we've been doing in the larger platforms. And I think the overall impression thus far is we started with a lot of capability, but not very mature. It's come together in the story that looks quite promising in terms of where we stand today. There are some questions still with the fundamental measurement, but looking at this overall version of putting the height measurement, the precision orbit determination, and the meter things is the prime place that we've focused on it, and I'll comment on those further as we go forward there.
Thank you. We will discuss a bit that in a minute. So Paulo, I see you next in the screen.
You're still muted, I think, Paulo.
I think we cannot see your microphone, so maybe is it connected, your microphone, Paulo? Well, we cannot. So maybe we go to João first, and you try to just check if you can solve that. Thank you.
Hi all. Nice to meet you, my fellow panelists. So yes, my name is João Janeiro. I work in S2 AquaColab. In a previous life, I did a lot of operational oceanography, focused on water quality, oil spills. But now I embrace the cause of aquaculture sector, and I'm working in S2 Aqua. I'm developing, try to implement emerging technologies into the aquaculture sector. These range from robotics, AI, and what I'm now focusing on, the concept of digital twin systems. So our goal, medium-term goal, is to have a digital system for all the aquaculture production systems that we represent in our collab, starting with the offshore, the hardest one. So satellite data is key into provide us data information, spatial and time relevant information for the offshore systems, and also to not only present but also past, to understand trends and to have data applied into algorithms and models that can predict and help us optimize the productions of fish.
Okay, that's super interesting. I guess for satellites, coastal areas can be more complicated, but we might discuss that later. So, Paulo, can you...
do you listen to me now?
It's solved. Yeah. Thank you. Yes, it's perfect now.
Oh, okay, it's the microphone. I have to always change the microphone here. I forgot. Sorry. My interest here in this altimeter. Thank you for the invitation, first of all, to be present here. And I'm an oceanographer. In terms of scales, I work more with mesoscales phenomena. So much of it related to coastal upwelling. So you can guess that I'm more interested in coastal altimetry. So to which extent from the coast we can have reliable data. I work also with edit tracking algorithms and edit track, so tracking some edits. We have some work done with that. But my main interest at the moment is the slopes that we can infer from the altimetry in the ocean in coastal regions. And my main area of work at the moment is the Gulf of Cadiz, to solve the circulation in the Gulf of Cadiz. Of course, satellite altimetry only gives us the surface, but we can infer a lot of what happens in the water column from the satellite altimetry. So it's my main interest on the subject is this one.
Okay, thank you so much, Paulo. So we heard from Arlindo that we have some challenges here, but we wanted to address with this project the science, technology, business. So we have these very different challenges, and I think I would start with the technological challenge, and maybe go to Professor Byron. So Magal is a new concept. We know that we have these decades already of altimeter data, and we know that we have these big instruments that have different payloads on board also to help us to have very accurate data. Do you think it's really possible to do these kind of measurements from a new space perspective? So with these very small CubeSats, and what you see, or what have you found with this project? Also, what are still the technological challenges that we need to solve to be able to do that? Thank you.
Yes, the question, the issue, looked at in the context. There was a fundamental question when we started this a couple, 3 years ago about delivering this challenge. It's a very, very challenging measurement that one sets out to make in this domain. I drew an analog to this, and I probably should have mentioned this in the original discussion. I became involved in this process back in the CSAT days, right at the beginning of the altimetry, space altimetry domain. We draw an analog to the problems we were looking at in the CSAT domain. I led the precision orbit determination altimeter team that was responsible for the fundamental measurement. Look at the challenges there, and then looking at the follow-on thing, I had the same role on the Topex Poseidon. And we actually had fundamental measurements that looked very, very difficult. Over the time frame, we were able essentially to make advances to reduce those to go forward on it. I've seen in the 3-year progress something similar to the sorts of challenges that we formulated at the beginning of the project here, and where we've matured to it. At the beginning, there was a fair amount of capability with aspirational things, but the story that comes together now looks quite good in terms of putting a capability together. There still are, from the point of view of, I think, all of us that's involved in the measurements, some fundamental concerns about the precision, the accuracy of the fundamental measurements. Most of the tests have been conducted in a short range spatial domain. How those translate into the orbit comes into play. There are, I guess, two fundamental concerns right now. The fundamental precision of the measurement is larger than one would have if one wanted to compete for the sorts of measurements that's being done by the flagship missions now. And I think improving those would probably something we'd want to strive to do going forward. The question of what the fundamental limitation is not clear to me at the present time. I could have perhaps penetrated this had I been able to attend the second workshop, which I couldn't do. But that, I think, is one of the things we want to look at. What is the measurement? The actual accuracy budget at the present time looks in the form of essentially the instrument precision itself. Still doesn't look at what one would have to do to overcome the error contribution of the wet troposphere and the ionospheric effects. Those are essentially not in the overall error budget. And it also isn't clear in the precision of the budget that's laid out now what the role of the precision orbit would be. I think that's probably something that is much more amenable to current state technology. The questions of what we have to do with the fundamental measurement, I still think is still an open question. But again, looking at the cup half full versus half empty, it's a very substantial set of progress that's been made to date. There is an interesting dance going on now about what one could do. The question of taking the fundamental objectives of duplicating a measurement consistent with what's done by the current suite of measurements that's on orbit over there. May or may not be possible depending on what we can do with the fundamental measurement itself, but there still is a question of backing off and looking at what one could do with a constellation of satellites of less precision going forward. I think that's still a dialogue that if going forward one would want to have looked forward. So there's the measurement accuracy, what can you do? There's the constellation, what benefits could that bring it with less accuracy going forward, that I think would be an important dialogue to be had going forward. There's probably other points, but I've gone longer than I probably should have here, so I'll stop at that point.
Yeah, thank you. So I think that could be very interesting also to analyze. I'm thinking of the planet constellation that uses Sentinel-2 as a reference also to be able to use their data more accurately. So I don't know if there could be any synergies between the reference, the Sentinel-6 already there, and this sort of constellations. Do you think that could be something to consider?
This is one of the important things I think that I would be thinking about looking forward there, what you can do value added. There's also the question of one of the things that information content that can be brought into the domain beyond what the actual instrument itself, the single constellation itself measures, is where the ground tracks will cross over. This will be an inclination that allows to cross over all of the paths of all of the other satellites. And the dual crossover information, the difference in that we use pretty extensively in the earlier satellite mode to bring additional information into the domain. And I think this is something that could be done to help provide both validation, calibration of the on-orbit measurement. It also may be a way of actually, depending on what the limiting error sources are, it may be a way of actually bringing information into that, particularly with regard to the medium effects, the ionosphere, wet troposphere effects, those effects over there. Information could be gained during that mode over there. These are ideas that haven't been fleshed out very much, but are something that would be a workable thing to take up as we go forward in the plan.
Okay, thank you. So maybe I will go now more to the scientific challenges. We know that we have these decades of data of altimetry from reference satellites. So Sentinel-6 is now the reference satellite. I was going to ask maybe each of you, or maybe we can start with Paulo or Fabiola. How are you using altimeter data already in your work? And what is something that you can still not answer, some scientific question you cannot answer because you don't have enough altimeter data, and that Magal could respond to that, could answer that question. So what can you do now, and what do you think that you could do if you had this sort of concept would work? Let's put it like that.
Well, I think that my answer and Dr. Paulo's answer will be quite the same. So I give him
okay,
the opportunity, and I can complete if some information there.
Okay,
so Paulo, you can start.
We start from the south to the north. Okay. What I'm an end user. I'm a stakeholder of the data. So what here our colleague Byron told us, it's very interesting to listen, but it's something that to us is a bit out of our scope, as you can guess. As I told you, we work a lot with the slopes in the slopes derived from altimeter data. So we are more interested in slopes in relative altimetry than in the value, the precision itself. So that it's a good product for us is a good comparison between 2 points. So most of us, we try to rely in gridded products. And gridded products, as far as I know, they are very tricky. And because they are constructed upon different passes of the satellites, so it's difficult to infer slopes. Well, when we do heavy tracking, we rely also on slopes, not in the absolute So we look for the sea level anomalies or dynamic topographies rather than the value itself. So everything that if Magal can solve these kind of products, lately I'm giving an eye and I'm following what happens with SWOT, because SWOT gives us a swath, it's a different word, of 50 kilometers, more or less. So we can have slopes in 50 kilometers. And that it's again, it's a step forward for the oceanography to solve surface circulation, because from these slopes we can infer the ocean current and the ocean circulation. And if we have long time series, of course we can infer the changes in the circulation. So our interest is more this one, is to infer slopes, to add relative products from one point to another, and that it's to ask too much, I think, to try to push these good results of altimetry for coastal regions where traditional they failed. I don't know if Magal can bring a step forward on that. That it's more a question that, but it's our wish. We dream with that, to be honest.
Okay. I don't know, Fabiola, if you want to add something, or
Yeah, this is more or less the same thing, but with an eye to the north. So I work in the deep sea to coastal regions. I mean, continental shelf region, and which concern the deep sea. I mean, the open ocean. I'd like to have a good representation for example, small eddies that I know that are more recurrent and can add energy to the eddy connect energy in some energetic regions like the Azores current, and more closer to the slope and the continental shelf. I used to track some features like filaments and small mesoscale features like meanders related, for example, to boundary currents that can have impact, or at least can add forcing to the regional and local circulation that in the end can impact the trajectory of some drifters like oil, sediment, or upwelling, etc. So as Dr. Paulo said, it's a wish that you have a better representation of these small features closer to, I mean, in the open ocean, so you can track it better the eddy connect energy, and also close to the slope and the continental shelf.
Okay, thank you. Dr. Byron, you want to intervene?
Yeah, I wanted to maybe add a comment following from Paulo's comment over here. I think that's one of the things that that I've been sort of thinking about with regard to this. Rather than the absolute measurement, the differential measurement between the things going across, leading into the slope type things, and the actual point you make about the importance of SWOT. It's a very, very interesting measurement on a single pass. The time between that pass is relatively long if you're looking at offshore dynamics, and the possibility of using differential measurements for the Constellation to help feed into to that, I think would be something that would be the sort of thing that we ought to be thinking about if we're hung up into this fundamental height measurement conundrum there. But I think that's a very interesting fact that you essentially focused in on that particular point there. Thank you.
Thank you for the input. So I think maybe we can add João here to the conversation also on the use cases, because you work specifically with an application with aquaculture, and we have these use cases that were mentioned before, specifically sea surface topography, eddy detection and tracking, marine debris monitoring, and inland water levels. These were 4 examples mentioned. I was wondering if you if you have other use cases that you've been thinking of, or if you foresee that which of these will be more helpful for your work, maybe. I don't know if marine debris will be easy to challenge, easy to tackle. And also considering the business, do you see aquacultures willing to buy data or to buy an added value product from your digital twin, or you buying data to Magal? So a bit of these two components. So usefulness and the business case.
Well, regarding the usefulness, of course, all the data is useful. It always depends on the imagination of who works with it and their availability, of course. We have several challenges in the offshore, mainly on the offshore, that this could be, this type of information can be useful. But from what I see, not in a direct way. So I don't see myself using in my day-to-day studies or work direct altimetry. But when you consider that most of the reanalysis models, most of the forecast models are using altimetry data for its in its assimilation processes to improve their solutions, this type of technologies is absolutely necessary in order to have better forecasts, in order to have better indcasts, to have better reanalysis data. So this type of product will help me a lot in what regards the currents, understanding the currents on our sites, which will then help define the best aquaculture sites that we are combining with other information, of course, can decide which are the best sites for deploying aquacultures, and also to be able to monitor changes, like rapid changes in the ocean currents, like storm surges and stuff like that. Regarding the use cases that you mentioned, marine debris can be, and from the ones that you say, probably the ones that I could relate more. Not only marine debris coming to the aquaculture sites, but also marine debris going out of the aquaculture sites as a tool for monitoring the pollution events from aquaculture sites. Regarding the buying information, it's already happening. I was in another conference a while ago, looking at the issues with the digitalization in aquaculture, and one of the questions that I was asked was about the willingness to pay. What was the issue? And I said that the issue is that aquaculture until now, it was mainly kind of a familiar business, small scale businesses. But now, due to the importance of aquaculture, the big players are starting. And when they are starting and they are targeting the ocean, they look for optimization. And when they look for optimization, they will look for data. They need to look for data. And when that happens, either directly or indirectly through services that use that data is getting paid. That's why it's important to have a system like the data center system that is able, a data center system that is able to track these either with a marketplace or I don't know. Because otherwise, who gets the funding and the money is the people that, like me, work with the raw data or the processed data and can transform that into services. If we are able to use the data and transform that into a product that then can be shared in the marketplace or sold in the marketplace, let's say, probably the synergy between the data producers and the end users could be more direct, in my opinion. I don't know.
Okay, thank you for that perspective. I'm always interested to understand this. involvement of aquacultures, because sometimes they are very keen to participate in developing projects or research projects, but then when the tool is available, they are not so willing to pay. But as you say, I think things are evolving also. So maybe that we
But
will.
that's human nature. Sometimes
Yeah.
that's human nature, because it's very difficult if you have a process that works to implement a new process, even if you promise that that it's going to be easier and it's going to be faster and it's going to be optimal, it's very difficult to change. But that's human nature.
We need to show them the value of that in numbers, no, probably in euros.
Yes.
Okay, Paulo, I see that you have your hand raised, and I don't know, Byron was also having his hand raised. I don't know.
I think Byron raised first.
Yeah.
I think Byron raised first.
I'm sorry, I actually thought I had lowered I see.
Oh, okay.
And I didn't really have it raised. I had it lowered. So
Okay.
I'm sorry, I'll go ahead and follow.
Okay, thank you. Yes, from our point of view, only to make a point, or 2 points. Two points. First, we are very interested that Altimetry solves sea level over the continental shelf. That it's a wish. I don't know if integration with tide gauges can be done or not. Second point, we only have, from my experience, our experience, we only have accurate slopes along the satellite track. That it's very nice if the coastline is aligned with the track of the satellite. In our case here in Gulf of Cadiz, that's not true. Actually, the tracks are almost perpendicular to the coast. And we are trying to calibrate. We just installed last week 2 pressure sensors in 2 points here, very far away in Algarve, one close to Sagres, close to the west, another one close to the east. And we are interacting with the Sentinel-6 data in order to validate this data over the shelf. So we are measuring with the pressure sensor installed in the bottom. We are measuring the high of the water column, the sea level high, and in order to validate with the satellite 6 and to see if we can infer products, etc. So we have this data, we have these pressure sensors installed that can be useful for calibrations, etc. They're open to it. That's all for the moment.
Okay. Thank you. So offering data, that's it's always good. I don't know if
yes, offering data for free. And as oceanographers and researchers, we always expect that Altimeter data comes for free too. We didn't question our business; it's problem of business.
Thank you, Paulo. So we have, I don't know, I think we have still 5 minutes for questions. I don't know if anyone in the audience would like to raise any questions. Any questions online? No one wants to make a question? Okay, so I think maybe I could just wrap up a bit this panel. There are still challenges ahead, that technological ones, but are the ones that we have seen before. So there's optimism, and the thing is keep solving the problems that we see and maybe find synergies with the reference satellites that are there and try to explore how to improve the measurement of the data, but also looking at gradients, at slopes, at other things that might not need to rely as much as inaccuracy as other types of measurements like sea level height that needs to be very accurate. There is this need for improve coastal measurements also. I don't know if that can be post processing or if that can be done by technology. And there is the need to make the data integrated and accessible to end users for specific applications. So I don't know if any of you panelists wants to add something to our final note before we close this panel, or if we are all good, or if you want to make any questions to each other.
I just want to ask if it's possible to integrate the satellite data with remote sense data with ocean color, because if you can have a good representation, for example, temperature of the ocean, you can track some mesoscale eddies with short resolution, and also can track some filaments and maybe with luck the upwelling systems close to the coast.
Yeah, that's a good question, because Sentinel-3 is actually doing that, now having OLCI, SLSTR, and AR or ASR. I don't know I never know the altimeters. Yeah. So it's kind of a good synergy, because you get color, temperature, and altimetry. So it would be very interesting to understand how this Magal constellation could really synergize with all the other types of sensors. I don't know, Professor Byron, if you want to say something.
Yes, there was one thing that occurs to me. It was in the earlier altimetry, and I haven't followed it recently to see whether it still plays a role in there, but there is information on significant wave height in the altimeter return measurement. That's both interesting from the measurement point of view, and it's also at one point it was used in actually as a commercial product if you're looking for places where you sell it and trying to look at ship routing based on that. And the ocean dynamics in the area in and around Portugal is fairly significant. A lot of shipping goes through there, and there may be potential for that particular factor to come into play in the applications. And I don't know, I can't find it discussed any place in the discussion modes, and so I think that's at least one thing we'd probably want to at least think about a little bit going forward. But thank you.
Thank you. Okay, so yes, just another question. Yeah.
Byron said, because from altimetry we have the sea surface height, but we can derive the sea significant wave height and wind speed as well. Mm-hmm. And this could be the kind of products that, for example, for offshore energy and wave energy studies, we can use the significant wave height measurements from the satellite altimetry and in order to derive some kind of model and product which helps the offshore energy.
Okay. Yeah, offshore energy is maybe a good case study also for this. Let's see. Okay, so I will just thank all panelists for being with us this morning or this afternoon, depending on where you are. And so thank you very much. And we are going to, I'm passing the floor to Arlindo because he's managing the, the session. So thank you very much, everyone.
Thank you. Thank you for the invitation.
Bye-bye. It was a pleasure.
Thank you, Carolina. Thank you, all panelists, for this excellent assessment or discussion on this topic. And just before closing the session in the morning here, just to highlight 2 or 3 points that we're discussing or were addressed on this topic. Indeed, offshores is one of our business cases, not officially addressed, but we can easily answer it. So from the use case that we have selected and the data that we have, we can surely address them directly without major problems. Regarding coastal, we cannot, I won't say that Magal will solve or will overcome all the issues or all the technological issues or problems that we have. But what we can say about Magal is that being in new space, we can have more constellations, we can have much more data to use it. If this data is validated and consolidated, it can help both science teams to develop new algorithms, new processing tools, and forecasts will be better, sure, no doubt on that. From the engineering point of view or technology or technological point of view. Coastal addressing on Magal, we have introduced it on the Radar Altimetry that we will show this afternoon. One feature that we call it range profile that will help us to discriminate in real time each at data rate of the Magal inside the radar cross-section data that we receive back from the reflection of the oceans. We will be able to detect several peaks on it. So, in principle, and unfortunately, we could not have field test results on altitude today to present. We will do it in next weeks. We have some issues with the setup and we could not fly it, but now we are ready to do those tests. What we saw in ground tests is that we were able to discriminate in a single measurement different reflection points, different altitudes, which means that potentially we can answer partially at least to the coastal region issue. But this needs to be consolidated with field tests that we will do next week. If we can add this additional added value to Radar Altimetry together with the temporal solution of 5 days that from orbital design we can achieve. And being a new space approach, I will say that it is already a big step on the altimetry radar for ocean monitoring. So now we will have a break for lunch. It will be roughly 1 hour, so we shall be back about 2:20 Portuguese time. So 8:20 Austin time, 3:20 European Central Time, and then we will address the radar altimeter prototype that we built for Magal. It's ground results, so it's the first test results, and these address also this technological add-on that we have introduced with range profile, and then we will try to address also this sector and stakeholders funding of this sector, which is, I would say, one of the biggest challenges of the sector for the coming years. Thank you for being with us this morning. I hope you can continue in the afternoon, and we will come back in 1 hour, more or less. Consegues me ouvir?
Sim.
Tá bem, tá bem, tá bem.
Okay. Sorry, we had a small issue with audio on the auditorium. We will start now the afternoon session of the Magal Altimeter final workshop with presentation of Radar Altimeter prototype and its preliminary results on ground and its topology. I will leave Daniel Albuquerque from IT Aveiro do this presentation. Daniel, floor is yours.
Thank you. So I'm going to present the radar altimeter firstly.
Camera is on.
Yeah, camera is on. So I'm going to present the radar altimeter first results, some tests that we done, okay, and some nearby future tests to close the project. Oh, thank you. So I'm going to start by the main idea that we have to try to use a radar altimeter in the CubeSat, and that idea comes from the automotive world. Okay, so in the automotive world, they have that problem also to have a very small radar that consumes less power, and it is very simple to implement. Typically, in the automotive world, they use 77 gigahertz. Okay, so our approach is try to convert that radar to operate at 13 gigahertz. This brings several advantages. Okay, the most important is the simple design and implementation. Okay, they present low digital signal processing resource. You don't need to have a very powerful DSP. Okay, the most important for a CubeSat is the low power budget that we can achieve. Okay. For that, of course, we need a high gain antenna to achieve that, but it's better than use a typical SAR approach. Another important part is the resolution. Okay, so the resolution of this radar is only related with bandwidth. So if you want more resolution, you increase the bandwidth and so on. Okay. And at the end, we're going to have a very accurate and precise data to analyze, to have information regarding the area that you are observing with a single radar pulse. Okay, that is called the range profile. So here I try to summarize the operation. So it's very simple operation. It's based on frequency modulated continuous wave, FMCW. Okay, the idea is to send a pulse to Earth and receive the echo. And we only need a single pulse to gather all the information that you need in that area. Okay, here I have an example of a tube. The tube is a very simple wave, it's a sine wave that the frequency change over time. It starts at a low frequency and the frequency is going to increase over time. In this case, it's linear, it's the same that we are using there. So we send these pulses. Here I put a periodical pulse, but it could be spaced in time depending on the sampling frequency that we need. Okay, so due to the distance to Earth, okay, the reflection comes some seconds later. Okay, so we're going to receive this signal, our signal, the green one, after some seconds later. Okay, and if we multiply both signals, so if you multiply the sent signal by the received signal, we get a bit signal. Okay, that is the difference in frequency of both signals. Okay. So if you make and transform this signal to frequency domain, it's possible to have the called range profile that gives you the frequency difference between the shapes. and receive it. Of course, if you increase the distance between Earth and the satellite, okay, they're going to change the position of the green signal, and of course, the frequency difference is going to be different, and so on. So from that information, okay, from the frequency that you are receiving, it's possible to compute the range distance, okay? So now I'm going to talk about a little bit about the front end. This is the front end that I have there, okay? This is, they have a chirp generator, okay, that generates the chirp. After that, you need a power amplifier, okay, to put power in the transmitted antenna, okay, that sends the chirp towards the Earth, okay. The chirp reflects in the Earth's surface and reflects back to the satellite, okay. Of course, you need to have a receiver antenna, or we could use also the same transmitter antenna to receive the signal, okay. The receiver signal need to be amplified with the LNA, a low noise amplifier. After that, we need to multiply both signals to accomplish that math property, okay. We need to low pass filter. This is a simple thing, sampling to the digital world, okay, and perform some digital signal processing features that is converting the signal to the frequency domain to obtain the called range profile. So here I'm going to present two prototypes. This is our first prototype that we developed, okay, some 2 years ago. They have only the radio frequency part, okay. The remaining part is the acquisition part is made by an oscilloscope, and the processing part was made with a computer, okay. This is our first prototype that is operated in the ground. This prototype I have there, you can see that. This is our final prototype that we want to use and to explore the functionality of them, okay? The antennas are changed, all the signal processing is made there, okay? They have processing power, they have a FPGA to process all the information and so on, okay? Another important feature, you could operate it remotely, okay? I'm connected with a Ethernet cable, but you could connect it with Wi-Fi or 3G data. And that you are connected with to operate in the field. Another feature that you want to add is battery power. Right now is ready for that, but it's not operated by battery. We need to have some mains supply, but it's easy to convert it to battery power. You only need to 12 volts supply. So we carry some validation tests. The first validation test that we carry is using a wooden board covered with aluminum foil, okay, to have a very sharp reflection. Okay, these reflections are created by the foil and back to the radar. Here is some inside lab tests. Okay, we can put there the distance in meters. Okay. Here you have, you have the measured distance by the radar, and this is the true distance using a laser point to get the distance. And you can see that the error is always below 16 centimeters and in average around 5 centimeters. Okay. Here I put what I call range profile. It's the information that you could get from the distance for different distance. Here I put the 13 meters away. You see that you have a very sharp peak at the distance of interest, where is the target. Another field test now outside the lab, into a corridor that has, I think, 60 meters length. Okay, and we bring the target there and you try to measure the distance to the target. Another thing that you could see that there is some walls that could produce reflections. okay, near that arrow marks. So the first one that we carried is this test that the target is more or less at 60 meters away. And this is what you get from the range profile. Okay, so you get all the information that you are sensing in the single shot. Okay, so sending only a single pulse, we could gather that information. Okay, so we have some marks here. I don't know if you could see it, but it's very easy. This is the purple one. It's the first one that you receive it. Okay, here we figure out that it could be this wall. This one represents that wall there. This is another corridor that is there. That one is going to be that position. The red one is a true position. This is a target position that is at 60 meters away. Okay. Of course, the target is big, is metal, so it's going to have a very sharp pulse. Okay. This is the results for different distance. We start at 6 meters and end at 60 meters away. Okay, you could see that the average error is around 17 centimeters. Okay, and you could see that at 16 meters we have only 8 centimeters of error. Okay. Another important thing that you could see that is the error is not depending of the distance. This is very good results because if you increase the distance to Earth, it could be a big error. And this proves that the error doesn't increase with distance. Okay, you could see that also that you have 1 meter here of error, and our idea to have this error is because of that wall there, the blue one. We have a wall there, a metallic box in the wall, okay, that reflects at the same distance of interest. Okay, you have the target at 33 meters, and you receive a measure produced by that box also that is integrated in the information and increase the error. Okay. We made also some additional field tests, not in altitude. This is the last part. In distance, we try to validate with buildings. Okay, to see if you can find the buildings. We have 3 different tests. One is for this department there, another department there, and the last one is this department. So I'm going to present each one. So I'm going to start with the nearest building that we have. The radar is placed in the rooftop of this building on your left. It's not easy to use the mouse. So we mark it with the yellow mark. Okay, this is the rooftop of the building, and we face the radar to that department there, marked with the blue mark. Okay, and the results of our range profile is this one. Okay, the first one that we received, we put the radar up, but we receive some echo from the wall of the building. The wall there, near the yellow mark, there is a wall. Okay, and the first, let's try to use the first mark there is the wall of the building that we are. Okay, and the yellow mark there is actually the distance to this wall there. Okay, we try to mark here the lines, but it's Google Earth, and the distances are not very well computed. Okay, so we could see that you get different peaks at different distance. This meaning that there is a reflection with that distance. Okay, and if the surface is bigger, you get a bigger reflection, and the opposite way. Another one that is that building. That building has a flat surface that is very good reflective one. Okay, and here you get the same results. Okay, so from the building we get a very sharp peak there, a very sharp peak, and you also get a very huge peak there that is due to that corner reflector. Okay, the corner reflector is a very good reflector for RF. Okay, so due to that corner there in the building, you get also a peak there, okay? Hopefully you don't have that in space. Now we try to do a different approach. We try to put the radar in that corner there, yeah, that corner there. And we try to figure out if you could get this distance from this building and other distance from other buildings, okay? The way that we think is if it is possible to go to both the city and get to the ground floor and the buildings, for example, that's the idea that you get, okay? Try to get the information that you will compute with a SAR, but using a single pulse. So we did that approach, and if you could see, you get two main peaks, okay? The first one is difficult to obtain. We don't know what is the reason to get this peak, okay? Probably is metal structure that is there in that place. Oh, I don't. Where is the mouse? There is a metal part there. Probably comes from there. Okay. The bigger peak, the purple one, this one, is from the first building. Okay. The biggest flat building, and the last one that is these small peaks there. Okay. These small peaks there is from this building there. Okay. Another important thing is that these results are not carried out with a very sharp cross section. Okay, it's very wide cross section. We changed the antennas now. You have now a very sharp cross section to get better results. Okay. So the final steps and some add-ons that you want to add, we are working on that right now to finalize the project and have some more results. The first one is to try to finalize the real-time acquisition. You, at the end of this workshop, you're going to see it operating there. Okay, it's acquiring and show the incoming signal in real time. Okay, we want to compute everything in real time there. Another thing is to operate remotely, hopefully by internet. Okay, right now it's operated by Ethernet. If you have a Wi-Fi, you could operate it remotely, but we went over internet to be easier. And of course, made some altimeter tests. Okay, we have some ideas to do that. Okay, hopefully we have time to do that. It's not easy to get time for this type of tests. The first very simple test is using a bridge in Aveiro from the autoroute there, and try to get information from the saltwater river that is there. Okay, this is the first one. The second one is try to use a drone. This is a very low payload. If you pick it, it's not very heavy. Okay, so the heaviest part is the batteries. Okay, so if you could, we will try to use a drone to operate it. Of course, this is another idea to use a hot air balloon, okay, to get the information from the ground. And the final, of course, is using an airplane, okay. We already have some conversation with some parts to get that airplane tent to use it and get some information, okay. So that's all. Thank you.
Thank you, Daniel, for this clear presentation on Radar Altimeter. I don't know if someone has any question, or from the audience, you can write in the chat questions on the topic. Yes, please, Nelson.
So you didn't make tests on the sea for now, just on land, right?
Just on land and in the horizontal way.
Okay.
That is the worst tests because we have a lot of reflections from the ground.
Yeah. Yeah. Do you have an idea about the footprint, the lens contaminations, the footprint? If you what kind of steps you need to manage and to tackle the land contaminations on the footprint when you just survey ocean areas?
If you survey an ocean area, if you don't have ground, that's perfect. You don't have any problem. When you go to the ground, there is it could be that problem. If you have footprint, if it is at the same distance, for example, if you have the same distance, you're going to integrate the information. Okay. Of course, you could use some processing, signal processing power to get the far away distance could be the ocean and not the ground, hopefully, because you have a profile. So probably you could get the information that is from the ground, separated from the ocean. Okay. Otherwise, when you have a very gap in the coastal area, for example, if you have a gap, you are going to have two different peaks. Okay, because the information is not integrated in the survey area. You could have different information for different distance. Okay, I think that's the most advantage of using FMCW instead of a very simple pulse emitter. Okay, it's not SAR, but it's close to.
Okay. Just one last question. It's about the waveform. The altimeter, radar altimeter and satellite, usually we have access to the waveform, and after we tracking the waveform, we can derive the oceanographic parameters. I didn't see any kind of waveform with the leading edge and the trailing edge, and from there, in order to derive the oceanographic parameters, we expect to achieve the same kind of the same form of footprint.
Yeah, the range profile, we hopefully get the same information from the range profile. Okay, we have 20 centimeters, I think, of resolution. So the idea, and this is a raw resolution, you could increase it, is to add that information of the waveform. Okay, that's the idea. We didn't test it. Actually, we did carry out some simulations. We have some preliminary results, but with artificial weights. Okay. And you have that thing. Okay, you have the
leading edge, the slope, and the trailing edge in order to derive the oceanographic parameter.
You have some clues about that. Okay. But you need to study and to figure out, because the waveform is different, and figure out how to get that information, specific information, to compute that.
Right. Yeah. Okay. Thank you very much.
So, any other question? If not, thank you, Daniel, for this presentation. At the end, before closing, we will try to do some live demonstration of Radar Altimeter prototype. So we have the hardware. Just a second. We have the hardware here in the room, as you can see. And we have a laptop connected to it where we can see and its performance and its results. We will try to do this trial at the end of the session, and we will try also to stream it at the end. So now we will move more to the next agenda topic. That will be our second panel part for this event. That will be focused more on the stakeholders and the funding of these activities in this sector. So, Radar Altimetry, ocean monitoring, Earth observation, all the new space sector and the increase or moving of the exploration and the Earth observation as a whole made by the new space domain will change the way we see data. We use the data and we assess the service and products for our daily activities. So here we would like to hear a bit the stakeholders' position on their use of the data, their ability to fund or support this type of developments, how do they see the access to this data and fund their development. To moderate this debate, we will have Pedro Lacerda, a project manager on Portuguese IPN, in frame of his BIC, Portuguese BIC, so the Business Incubator Center from ISA. As panelists, we will have Santiago Cavalero from SETGA, the aquaculture business in Galicia. Is a director there. We will have Gilberto Carreira, the director at Direção Regional das Políticas do Mar Açores, more on the public service and the support of the this sector, and on the funding service or funding entities, we will have Pedro Calhas from Portugal Ventures, that is an investment manager there, and potential funding services. Pedro, I will leave you the floor to lead this debate. I will also invite you to present a bit more your profile and your activity, and please proceed from here. Thank you.
Thank you, Arlindo. Okay, good afternoon, everybody. Thank you very much for Arlindo for inviting me to deal with this debate, with this panel debate. Yes, I work at the Instituto Pedro Nunes in Coimbra, IPN, where we have a contract with the European Space Agency to assist in the creation of new businesses using space technology and knowledge. And although you introduced me like that and it's written on the screen, I'm not a project manager. As I usually say, I cannot even manage my own life. I am a scientist and I do research in astrophysics, but I was hired by the Institute because of their contract with ESA and to help translate technology and knowledge that comes from space-related research into Earth applications. So a bit trying to help that bridging, but my main activity is in research, which means that you know, it's a bit of a challenge to steer this discussion. But I think it's actually a good thing because it forces us to stay a little bit away from the jargon and of the experts and makes the discussion maybe more accessible. So as I heard this morning, this panel is about funding, so let's put the fun in funding. Anyway, I'd like to first start with the panelists and give each one the opportunity to introduce themselves in just a couple of sentences, highlighting how your institution, how do you think your institution fits with the concept of the Magal project? So we could start with Pedro Calhas, which is on the top of my screen.
Hello, everyone. Thank you, Pedro, for giving me the floor. So basically, I'm representing here Portugal Ventures. I think most of you might know Portugal Ventures. Portugal Ventures is one of the main venture capital companies in Portugal, with a specific mission to develop the Portuguese economy. And our main owner is the Portuguese Development Banking. So related to the subject, we have a close partnership with IPN, and we have done quite several investments and other divestments related to the sector. This partnership with IPN, we use to invest on a very early stage of the companies, okay? And we have a quite simple way of investing. We use to invest 100,000 euros per project, and 25% of this amount match with the grants related to the sector. And the other 70% of this amount we invest once some milestones are achieved. Okay, and and our mission is in fact to invest in the very early stage projects in order to give them the strength to develop the ideas and develop their mission too, because all these projects, they have a mission within. And so we have a quite good track record in this area, and we are keen to receive all projects related to the sector on our calls. Every year, the IPN used to launch 2 to 3 times per year some calls related to the ESA, and we go along with IPN and ESA in the investment. Okay, so we are keen to receive your projects if you need some kind of investment related to venture capital.
Thank you, Pedro. We'll get to questions about venture capital. Now let's move on to Santiago. Santiago, could you introduce yourself and SETGA in the context of Magal? Thank you.
Yeah. First of all, thank you for inviting us to this interesting meeting. SETGA is a technological center of aquaculture. We are dedicated to the aquaculture. The partners of the SETGA are the main aquaculture companies of Spain and Portugal. I wanted to explain what is going on now with the aquaculture. Now, aquaculture is now in the middle of a big revolution, because we wanted there are 2 kinds of aquaculture: land-based aquaculture and the aquaculture that are in the middle of the sea. We wanted to try to start to use the new data that offer companies or products like these products, because in particular in the aquaculture that we develop in the middle of the sea, as I don't know if you know, but the aquaculture is developed in big cages that are far to the coast, more or less to 2, 3, or even 10 miles to the coast. And these cages are exposed to the several conditions, to the environment condition of the sea. We wanted to measure, for example, the altitude of the waves, the alders, wind, the oxygen level, the temperature, all kind of products, all kind of physical parameters, physical and sometimes, if possible, measure chemical parameters that can affect our production. This means that, for example, now we are taking data from Copernicus that we are involved in this project because we wanted to use this data in order to try to evaluate what could be happening in our production in the future. This means that, for example, if we detect that high temperature can increase in the next hours, or the oxygen level can reduce, we can try to avoid for example, for feeding the fish. We wanted to use these new technologies, the new data, in order to modify our protocols, our production. But we should use this data with the TICs, with the artificial intelligence, and with the big data, with all of these things that the aquaculture at the moment not used too much, but we need to use in order to try to avoid the accidents and the problems that happen every year in general in all of the aquaculture, not only in the aquaculture, the Mediterranean and Atlantic aquaculture, in all of the aquaculture. And this is one of the jobs and one of the projects and the issues that we wanted to develop.
Thank you, Santiago. Now we pass on to Gilberto Carreira. Gilberto, could you introduce yourself in a couple of sentences and how you institutionally fit in with this project?
Sorry, Pedro, Arlindo speaking. I just received a message from Gilberto. It was invited or he had last minute PRPM meeting. He won't be able to join, unfortunately, to this meeting. So we have to proceed with just Santiago and Pedro.
Okay, we can actually then go a little bit into more detail. This is good. Okay, so let's. So I continue, Santiago. Now you just finished on this aspect of the importance of data and also algorithms treating data. It will be a lot of data, so you need also AI, probably machine learning. But you know, there's a lot of work involved in this. But my question also in in terms of the funding. Since these data are clearly important for the activity of aquaculture, do you see in your cluster partners any animo, any interest in or willingness to fund these types of projects?
We are spending a lot of money in evaluate and test, for example, drones, or measure these parameters in the water, and proves that we need to measure several parameters. It's true that, for example, it's difficult to find a product that works perfectly or works like we want in the sea. I don't know why is the reason, but the final question is that we need data. We are paying for get this data from the sea, but at the moment we cannot take this data with the quality that we need to in order to use for develop methodology or to use in the management of the production. This is for this reason we have the human resource to take control. That in some areas, for example, in some areas in Chile are permanently. There are some people that are working all the time in the middle of the sea, taking care of the cage, or in other areas in that are far from the coast. Everybody are there are always people that are taking this data in order to send the data to the headquarters in order to take the decisions. If you ask me to me, we can pay for a project for that get to us some information that will be relevant for our production. The answer is yes, but the question is, what is the quality of this data?
Okay.
Because now we can get some data from the public sector with the satellites that we are using. A private company can offer some data that increase the quality, the precision of this data. This is the question. And if this is happening, we can use, and finally depend on the price for sure. Price of this product.
So you sort of feel the need to sort of have some prototyping, some demonstration that this can actually add value to the chain. And that's what I'm sensing. Okay, Pedro Calhas, so the venture capital VCs can play a big role in the rise of new companies, obviously, and you are active in this space business, space economy. Do you think, in general, from your activities, that European, so this is a big thing in the United States, is much more representative. What is your sense of how the European VCs are aware of the opportunities coming from the space economy?
That is a good question. In fact, I think most of the VCs in Portugal, they are aware. Of course, they are aware. The question is more related to the stage of the company is, because from my perspective, I think when we are talking about an idea or a very early stage, there are not much VCs keen to invest. Most of them demand or ask for some traction. Okay, so and we see in the market, the founders, they have some kind of difficulty to convince these VCs to invest when they are really on a very early stage. Portugal Ventures, we play a big role in this because we in fact invest in the pre-seed and seed stages. Okay, so we are comfortable with that. So, and what we see together with us, we found some kind of business angels more active in the sector, or sometimes some corporate partners that used to work with us, they are also keen to invest together with us. Okay, so this is the big picture we have in the Portuguese ecosystem.
Sorry, I was looking for my microphone. Thank you, Pedro. Okay, but now we don't have Gilberto Carreira to give us a perspective also from say government institutions. But Santiago, since you deal with the cluster, maybe you have to interface also maybe with governmental institutions, and maybe you have ideas on this. I think that as we continue our efforts to protect our planet from the effects of climate change and things like that, there's more and more pressure from governments to demonstrate that they're actually doing that. And you know, probably in the activity of aquaculture, there's more and more pressure to do these activities in a sustainable way. So I had a few questions on this. One is, are those pressures already effective? Do you already feel that when you deal with that you get government institutions or local governments putting pressure on companies to be sustainable? And on those types of pressures, how do you see a project like Magal, a constellation of satellites measuring the level of the oceans? How do you see that addressing those pressures? And does that make it worth for governments to help also with the financing of these things?
Yes, it's true that we have a close relationship with the governments here and in several countries in Europe, even with the CIIMAR and the research that we are part of the European aquaculture platform. But I think that in relation with the pressure of the governments related with the climate change, of course, the calls and everybody are talking about this. But we have a pressure, but the pressure is coming from the environment. The environment now is affected to our productions. We are reached the highest temperature that we can imagine never in our history, or we never thinking that this can be possible. We are the temperature in the seawater are reaching temperatures that are too high for the species that we are cultivate. Species like, for example, in the Atlantic Sea, we are Portugal and Spain and Galicia are focusing in flatfish, in turbot and sole. For sole, it's not really important, but for turbot, it's really important the temperature that we get now in the sea. That make very difficult, or could make difficult continue with in the future with this species, or at least we need to modify some questions. In the Mediterranean Sea, for example, in Greece or in the south of Spain, in Italy, we reach temperature highest at 30 degrees. This is not the limit temperature. Limit temperature for a species like sea bass are 26, 28 degrees. This is normal temperature in the 10 years ago. But now, the last summers, the temperature reached this 30 degrees, but not one day. During a weeks of time, period of time, that this affected the productivity, the production, and makes very, very difficult to feed these fish, and affect for sure that when increase the temperature, reduce the oxygen level. At the same time, we know that with when increase the level of the sea, some farms that are close to the coast, it will be very difficult to continue with these farms. And now we are studying the possibility to use the offshore aquaculture system that are very far from the coast, to 20, 30, 40 miles far from the shore, and to cultivate at deep meters of around 70 meters, 50 meters, 70 meters. When we know that in the future we need to modify our technology. At the same time, we are using RAS system to try to control the temperature, all of the parameters. This means that it's not the question of the climate change and the pressure of the government that pressure to us. It's the environment that pressure to the companies, and the companies take care of this, and how, like, it's our companies, and the companies who wanted to continue to producing and earning money each year, they modify technologies, process, management, invest money in knowledge in order to adapt to these conditions with technologies, species, and so on. But for sure, the government are not ahead of us. We are ahead of the public sector, the government, because it's a necessity for the companies, for the agricultural companies.
Yeah, I understand that. Yeah, you are really feeling these pressures not from any sort of made up legislations, but really from the fact that the effects are visible and they affect your activity. Yeah, exactly.
Legislation is coming, but this is the climate change is affecting, or I don't know if this we can call climate change, but affecting very fast. Yeah, faster than we think before.
Yeah, it affects the activity, and that is actually the more important thing. Both of you mentioned when I asked you, Santiago, about would your partners in the cluster be willing to fund these types of activities, and you, Pedro, when I asked VCs going for these types of activities in space, new space activities, you both mentioned the fact that these things, it's important to know, a lot of these projects are at early stage. Both in the terms of application, you need to know, can I get the data that I want, or is the data not good enough? And from the point of view of investment, is there going to be any return on this investment? So if things are early stage, there's an amount of risk. And so in these cases, usually in terms of research, when it's low TRLs, early research, we go to public funding. And for example, European Commission, European Union funding. Pedro, the question for you is, how do you see in space at the moment the balance, and do you think the balance is right in Portugal and also in Spain, since we have here Santiago, between the role of public funding agencies and VC funding in the area of space, and using space also to inform our activities on Earth?
What do you mean exactly with the balance?
What I mean is I don't think, is there enough? If we're always going with VC funding, you tend to just focus on, you want quick return basically of your investment. And if you go with public funding, you have the aspect that every euro cent spent has to be justified and so on. But it's actually in these types of public funding that you have the research, you have the early stage. Whereas with VC, you also want to see the potential to immediate implementation. And do you think what you see in the companies that you are investing in terms of this balance between early stage but also potential return, that balance is also matched by the balance between the way these companies fund themselves with public funding versus VC funding?
Yes. In fact, when we are looking to these kind of projects, of course, we don't have too much data. We don't have the perspective of what kind of business it will result, because one of the difficulties we face is put the idea in the way to be a business. Okay, so we look at this when the founders get funded by the European grants, European Commission grants. We look at that with a positive insight. Was a positive point, and we feel more comfortable when these projects are engaged or in the middle of a consortium, because we know that the European Commission, for example, they have a quite straightforward mission for specific sectors, okay? And if they are keen to invest, and if these projects get these grants, for us is quite comfortable to see that the project was eligible for that. The other point we look at is the potential of the team, basically in the technical skills. So in fact, the curriculum of the founders, understanding in what kind of project they were engaged, okay? Even though, because at this stage is important, the quality of the CV, the technical skills of the founders, because that will give us comfort to understand how deep they understand the technology they are using, or they are creating, or they are inventing. Even though in the future we need to hire more business people related to the business in order to escalate for a specific business. So one point is, if the project get grants from the European Commission or other institutions, plus the technical skills of the team, that is where we bet the most, if we can say like that, okay? That is the comfort we get. Of course, you say, yeah, but with this idea, sometimes we don't get to the point exactly how innovative or how disruptive this technology is. Most of these technologies and the founders, they result from research, PhDs programs, and other research activities, and most of them will have a proprietary assets, okay? That also will give us some kind of comfort to invest in. Okay, so I would say that those three pillars are the most important when we are looking at these projects. Okay, so then what will result in terms of business and return on investment? So we have quite huge experience investing in the pre-seed and seed startups companies. Okay, and so we know it takes time. It takes time. So, and that's why I said on my first comment that we have a mission. So we are kind of VC, missionary VC. We are a mission to, when nobody believes in these kind of projects, we are there at least to give them an opportunity to get some funding in order to expand a little bit or to develop on the TRL, okay? So we used to look at this as a potential, not that much in terms of timeline on the return on investment, but try to give the chance to develop a disruptive technology, okay? But we are absolutely aware that takes time. That's why we used to give a timeline of 18 months, okay, for the development of the technology. And after that, if the project is good and the founders can develop the project after the 18 months, in some cases, we do follow-on investments, okay? So we reinforce our investment if we have room for that. We reinforce our investment to give them another traction for the next stage of the company. Okay.
Okay. Thank you. Yeah, that gives a good overview. Santiago, so aquaculture, the way I understand it, is the activity of breeding and raising and harvesting fish and shellfish and aquatic plants in a controlled environment. And this sort of an overlap. There's a big overlap, obviously, with the food sector, but there's also an overlap with the maritime activities. Just to give since we're here also with a investor, VC from Pedro is an investor. I don't know if you know these numbers, but I don't know. You might know more than me. What fraction of the food sector, say in Spain, does the aquaculture activity represent? So as a slice of the market of what people eat, say. And also, sorry, just to finish, also, and it gives you a bit time to think. And in terms of the maritime activities, so the exploitation of the oceans, and I'm thinking immediately of the offshores and energy collection, wind energy. And in that sense, is aquaculture also competitive in terms of a business activity with energy in the ocean? So two things, how much does it overlap with the other exploitations of the ocean? And how much does it overlap with the other types of food that people eat? If you know.
Yeah, I know. Aquaculture is more than the 50% of the seafood that the people are eating in Europe, in the world. More than 50, but it's clear because more or less we produce the amount of production of the aquaculture sector in million of tons is more or less the same that are the catching from the sea, the fishing from the sea, and but all of the fish that are fishing in the sea are not for eat, are for produce raw material like fish oil, fish meals, and other kind of products. But all of the aquaculture products are developed from use like food from human consumption. This is why it's important. You go to a market in Portugal or Pingo Doce or other continent or here in Spain to El Corte Inglés or Mercadona, you can see a lot of products, and mainly these products are from aquaculture. And if you go to a restaurant and you ask for fish, it's normal that the fish that you can eat is fish that coming from the aquaculture. Yesterday, I were in Madrid and go to a restaurant and see all of the fish that present to us in the restaurant, and all of the fish was aquaculture fish: turbot, sea bass, sea bream, migra, salmon, all fish, shrimp, all was aquaculture, and with a high price. This is at the same time the question. This is for the future. Aquaculture is the solution, and I don't know why, but finally we know that the people, one is adapted to it, because sometimes we are focusing Portugal or Galicia that are countries. Galicia is a region and Portugal is a country that has a historic relation with the sea and with the fishing, but this is abnormal in France or in Germany or in UK. The people don't have this close relation with the seafood. We have a cultural relation with the seafood, and we think that everybody is thinking like us, but this is abnormal. The people like the fish that don't taste like a fish. It's strange, but it's like with the poultry. The people don't like the wild poultry and like the farmer poultry because it's from the scratch. When you started to eating seafood, you eat aquaculture, and this is you are adapted to this. For the future is aquaculture. If you go to your country in Portugal and you wanted to know which are the fish that the main species that the people eat in Portugal is salmon, and in Spain is the salmon, and in France is the salmon, and in every country of Europe is the salmon, and the salmon is aquaculture. Aquaculture in cage. Second question: aquaculture could be combined with another activities. Yes, for sure. But with tourists, for example, it's difficult because the people don't like to see a cage when you are spend time enjoying with your friends or families. And we need to move far away from the coast because it's like the factories. Nobody wanted to see a factory close to your house. Nobody wanted to see a factory close to your hotel or your activity area. And we need to move far away in order to continue to producing. We can produce in the future big installation of wind energy production offshore. Yes, for sure. The project we can combine two projects, but we need to develop technologies. In these technologies, we can use the technologies that are developed here. But finally, I'm talking like private, not like public. We normally use mature technologies. If these technologies are not mature, the public sector should to help to the companies like this company to develop the TRL of the product until at least 7 or 8 before we invest in this technology. Yeah. This is the EU grants are for this, the MAR 2030 are for this, the FEMPA that is our funding, that EU funding is for this, for invest in BRICS projects or in projects that are not finished. And the EU and the government need to invest in this. And finally, the companies give them a step, but because the companies cannot lose money. This is the first item, the first milestone for all of the private companies, private or public companies. Nobody can lose money continuously, at least.
Yeah. So I see that. So from the way you describe it, this sector has a huge market share, has a huge commercial importance. I saw Pedro Quelhas taking some notes, which is good because it means that he's probably thinking this is an area that we should invest. And I really see it because of being at the Instituto Pedro Nunes, where we try to stimulate startups to start new business ideas using the type of data that Magal will produce. I really see that ultimately this is where when the ball is rolling, this is where the value is going to come from. Data like from Magal and other similar types of initiatives will enable creative people to come up with solutions and measurements and data and information that will be extremely useful to activities like aquaculture, which is hugely important for our society. So when the ball is rolling, I don't see a problem. It just seems that it's just the first steps, the first steps to get something like this, which is infrastructure that has to be put in orbit. So yeah, we're approaching the end of the panel, but this is my main takeaway: is you always need to start something. And one thing that changed, sorry, now I'm a bit going into the philosophy direction, but one thing that has changed also with even before the Industrial Revolution was this concept of trust in the future, where people, in the year 1500, if someone was born and they were cleaning the floor of a house, their children would do the same thing and their grandchildren will do the same thing. At some point, people thought, I cleaned the floor, but I want to open my own business. And you go to the bank, you get a loan and you start a business. And somehow this is what we need to keep thinking about, is that we need these data, we need this technology, we need some trust at the initial stages when the TRLs are low, but we need to put these things in place to give them the opportunity for new business to come out and new companies to come out. So Arlindo and the organizers of the meeting, I hope this was useful. I really thank Pedro Quelhas and Santiago Caballero for your contribution. If there's still time to have a question from the audience, please go ahead.
Yes, indeed. Thank you, Pedro, for this excellent debate on the topic. Indeed, we can have 5 minutes at least for Q&A. So if someone has questions, please, Ana Martins, you can talk. Please,
oh, thank you, Arlindo. Can you hear me? Can you hear me?
Yes, I can.
Good afternoon. I'm, for those who don't know me, I'm Ana Martins, and I'm part of the Magal team for the Azores under the financial program Azores 2020. So I heard all day, of course, all of these comments. So obviously, I would like to make maybe a few observations related not only with my field of work, oceanography, but also some experience under Magal. What was the purpose of maybe of the solution, the final solution we had for these nano constellation, but also some observations related with also what Santiago and Pedro just made that were quite interesting. So on the point of oceanography, one of the things in the beginning, and as you all know, it's very difficult to come up with a plan of putting the best constellation that can actually resolve or solve all problems for temporal resolution, spatial, geometric, etc. So we realized that would be extremely expensive. At one point, the question was, what can we improve? We are not substituting any satellites, but what can we give with this project and to improve something? And one of the things is, for example, I had personally this experience for some of the structures were spoken in the morning, mesoscale features like eddies and everything. Even the fishermen relate the problem, or they're spending a lot of fuel, time consuming to search, for example, for fish in the ocean. And in the Azores here, we don't have coastal, we have everything. I used to say, we say achoo, and we are at 1,000 meters depth, so it's quite deep. But one problem is that for the fishermen, this is really time consuming sometimes to find these fish that they, from tuna to all kinds of pelagic and demersal fisheries. And so they were really interested to save fuel. And one of the things by having, but what we have before, by improving by half, actually increasing twice the temporal resolution to 5 days, even for us in oceanography, sometimes we think we are approaching the ship, and sometimes we have to do a lot of sounding and try to find the feature, because we saw the image a few days before and it's not related with when we get there, it's not the same feature, it's not there, sometimes it's even 1 degree south of north. So that was one of the ideas. The question of the marine debris, it's very difficult, obviously, but that could be related with some gradients that we could see and we can judge about this. So there were a few case studies that the scientists and from University of Porto as well, and we talked about this possibility of improving. But I'd also like to say is that we had the experience of working with a very, very interesting, it was, I don't know if you know, aware of a PCP, was the first one in Europe, is a pre-procurement project. And we worked for almost 6 years. And it was a very interesting project because as scientists, I was in the project, but actually it was from buyers to consortia to satellites. So it was the first time there was a European project, a 4 million European project, that actually the whole project was to construct the services that the buyers really wanted. And for example, here for the, and that was Dr. Gilberto was supposed to be here, was for marine protected areas. This is a huge extension. It's one of the largest EEZ of Europe. So going in traditional methods is very expensive. And one of the ways was to do with satellites. So it's to actually construct services by satellites that could answer to the public, to government, some of the problems they have with the marine directive and so forth. And it was very interesting because I was through the first day of writing the project all the way as supervisor of consortiums. And it was really interesting to see what the buyers really wanted. I had personally the experience later on, as Santiago was saying, another project that we actually won a Copernicus challenge just 2 years back. And it was to construct HABs and to detect HABs, harmful algae blooms, with satellites. And again, it's still ongoing. It's a very difficult project. But one of the things is interesting is now we have aquaculture interested services, people that work in aquaculture that are interested not for us to detect the algal toxic algae. What they want is that we can predict 3 days before that they're going to have these, so that they can do some, they have some possibility of ahead of time to do something about the aquaculture offshore. Another interesting case we did was when we get CIIMAR's data, for example, for the Azores, you don't get with a very good resolution. So yes, you can go and get it from Europe directly, but it's very difficult for the end users and sometimes the stakeholders to understand this data. But they want it with better resolution. So we are able to do, for example, wave models that were better than CIIMAR's. And for example, one of the sites we did was aquaculture site, that there was a storm coming. The owner thought that it was going to destroy the whole aquaculture, and our model was showing, no, it's not going there, you don't have any problem, and we were right. But CIIMAR's model, which didn't have enough resolution, was telling that all that area was going to be affected by extreme storm. So this is to say that I think we are talking, but it's fundamental to involve the people who are interested to buy these services in the projects, because better than they are the ones who really know, and that's what Santiago was saying before, is you really, you shouldn't do just a general service. You really need to address the people who know better. They have their own enterprises, they know in the field what are the problems, and so you have to adjust those services for those owners or the people who have these enterprises. And I think, and it's an ongoing process. Also, the people who have, for example, if you have an aquaculture offshore, you can have sensors inside that would help, example, for us to improve the service by getting also in situ data. So I think either with fishermen or aquaculture or, other enterprises is really fundamental. And this, I'm talking by my personal experience, that you really need to involve. You just don't say, I'm going to offer you the world. It's an ongoing process that takes a lot of years. So I think it's really important to get this feedback from the people who are actually paying the service because they're interested to get particular answer from the scientists, from the, whoever are the data providers. And it's just, sorry, I took a lot of time, but I think it's really important to say that this is it's not a constellation that is going to respond to anything, but we believe by improving this temporal resolution, we can ameliorate some of the services that exist already. Thank you.
Thank you, Anna, for your feedback. Any other question from the audience, from the attenders? If not, I will thank you all the panelists for this discussion on this topic. We will proceed. It was, let's say, a learning curve for everyone here. Basically, what we still see here is that we still have a gap between technology, service, products, and stakeholders. Basically, stakeholders want to prove it data with ensuring quality, minimizing their risks, and this is perfectly understood. On the other side, on the developers and science and companies, we want to provide new service, develop new technologies, deploy them. But for that we need the funds. But for getting them, we will need to have a proven concept with some maturity already before we be able to sell it to the stakeholders. So this gap that we found from this discussion between funding of the new technologies and the stakeholders buying of them, we need to identify ways to overcome them, to make these new technologies, these new opportunities, and in our days and in the future it will be worse. The time to market will be very short to validate these opportunities. We need to find ways to overcome them, and in our case, put Magal in orbit to prove their value, giving more or better temporal resolution data, that more often data that at the end we are convinced that will allow better processing, better service, better products, will help science teams developing new algorithms, and from that, with more data, as I said, will give more quality that will surely fulfill the aquaculture and the other offshores in the oceans market needs for the future. Thank you all. We will proceed now with basically we will try to do a live event here of the radar prototype, just a brief demonstration to close the session with a brief summary of the achievements of Magal project.
Thank you.
Thank you.
Thank you, Santiago. Thank you,
Thank
Pedro.
you. Thank you.
Thank you.
So I will just ask 1 second. I will move the share of the screen to other computer for the sharing of the demonstration of Radar Altimeter. Just 30 seconds.
You are hearing me? It's okay? Oh, perfect. So I don't know if I'm sharing the screen. Yeah. Oh, please. I need to move the screen. I need to move the screen. Actually, go right over there. Okay, now we are seeing. So, sorry about this delay. I need to mirror the screen. This is the waveform that you are receiving right now. This is the waveform from a flat window and actually some chairs and so on. So here you could see that the main reflection produces a typical sine wave, okay? And the frequency of this sine wave represents the distance that I'm from the window, okay? The remaining part, you see that you have these different shapes. This is representing other reflections in the objects, okay? I actually want to bring here the profile that represents the distance over the space, but I couldn't have it done right on time. So I bring the wave, I try to explain it, okay? That's the idea, okay? So here you see this sine wave represents actually the distance from the object, okay? If we have two different objects, you're going to have the sum of two sine waves, okay? So actually, if you could figure out the frequency of each one, you could see the different distance, okay? So this is operating in real time, actually. Okay, if you, just to show you, this is in real time, okay? Sorry. I don't know if you have any question.
I have a question.
Yeah.
So these reflections, these other reflections, are reflections on other objects, or is it internal reflections inside some of the objects in the path of the signal?
Actually,
or both actually.
Actually, we have here two different signals. You could see that you have a sine wave, more or less, there, okay? And the remaining part is the processing part, okay? They are preparing to send a shear. So the signal actually is only this part, okay? So actually here you could say that you have only a very single strong reflection. But yes, if I move the front end for other place, you could see that you get different waveform shapes, okay? Now is front facing the Alvins, okay? And you could see that is a sum of several sinusoids, okay? But I'm going to put facing again the window, okay? Try to that's the right position of the window. This is a very flat surface, and this is a very strong reflection. But of course, if you move it to other objects, you could get different sums of sinusoids.
It's very interesting. Since I'm not in the room, I don't know what you're pointing at, so I could almost try to guess from the signal. But
now is a very flat window.
Okay.
And I'm going to move to the audience.
And I have a question. What is the angular size of the beam? So what's the angle that you're sampling, the solid angle?
Right now is 1 degree, but you could make less than that.
Okay. Oh yeah, I see the room now. Yeah.
Now Arlindo is crossing the path.
Yeah. Arlindo has a complicated signal.
Yeah, I'm not transparent to signal, yes. So basically, I teach someone by the RF room. But now you can see also the window that Daniel is talking about, where we are having the reflection, which is, I would say, 6-7 meters away from the Radar Altimetry, more or less. So coming back to the audience, now to the Daniel and the Radar Altimetry prototype.
Is the size of the prototype the same size that would be implemented in the satellites, or does it have to be miniaturized?
No, it will be much lower size. This prototype, as we are seeing here, has a large, or as for instance, internal power supply from the computer to allow us to operate it in batteries. It will, sorry, audience, I'm trying to see if I can zoom a bit more to see if, no, not this one.
There is a lot of empty space there.
Yes,
oh, yeah,
there are
yeah.
lots of empty space. I'm trying to zoom in a bit the camera. It looks like it doesn't work.
Maybe it's at maximum zoom. Oh, there we go.
My fingers. Nevertheless, there are lots of empty space that you can see roughly here, and there are lots of wires. The prototype is in this way for debugging and allows us to connect, for instance, oscilloscopes, logical analyzers, and many other hardware and measurement equipment to perform intermediate measurements and allows us to debug and mitigate all the hardware and all and those checks that were made during development and test of the equipment. So basically, it shall be possible, and it's the final goal of the Radar Altimeter, and we are convinced on that. We have made it on the past on Efacec side. It shall fit in 1.5 U size for a CubeSat. This prototype powered by, let's say, 28 volts standard voltage for satellites, or even for secondary voltage on the Magal, which will be the case directly from 5 and 12 volts from the power distribution unit, which will avoid the power distribution or power supply interface on the hardware. So the figures of the Radar Altimeter miniaturized, it will be 1.5 U size, about less than 3 kilos, 2 to 3 kilos on its height, and the power consumption below 20 watts in maximum power transmission RF, which is 1 watt by the way.
Very nice.
Any other question?
Yes, I have a question. So it's operating on with a KU band, right?
13 giga.
Yeah, 13 giga.
Yes.
And I think the main challenge now, how we transform the signal into oceanographic parameters. So how do we remove all the noise, the instrumental noise, and apply the geophysical corrections and the seismic corrections and so on, and also transform this into reliable oceanographic parameters. This is the main challenge.
Yeah. I would say that it's a challenge, but it's also addressed and already discussed it under the frame of Magal project. So for Magal project, this is defining. All this data that we are seeing here from Radar Altimeter will be downloaded to the data center. On data center, we will apply the equipment corrections at level 1. So we will do test corrections. Then through that API, Paulo can explain it better than me, it will be moved or transferred to the science teams that will apply geophysical and all the process and algorithms needs to provide service and products to move the data for level 2, 3 for it. It will be returned for the data center, which will be then displayed for the user. So all these steps are already identified. All these process and algorithms are listed and identified. It hasn't been yet implemented since we don't have real data by right now for Magal. So this will be the next steps of the follow-up project. We will need to implement these algorithms and validate their implementation with real data from Magal. So, any other question? So I will move back the camera to the audience. I will move back again to sharing computer to presentation to wrap up this final workshop of Magal with the achievements of the project and the next steps or the open points or questions that we could not address or properly closed under Magal project. So okay, let me just pick up the right slide. Okay, So Magal basically has their objectives defined in 4 directions at this beginning of the project. On scientific side, engineering side, technological and entrepreneurial business direction. So what we can say from our studies and works carried out with Magal is that on the scientific side, Magal, we can conclude that Magal achieved almost all of its objectives in that scope, since we were able to set a complete mission, constellation, list of requirements to perform altimetry radar, focus on oceans monitoring, and break down those requirements to payload level and all its characteristics. Also, we were able to set and define the list of services and products to be delivered in our data center for